So what we're going to go through today, and this hands-on lab, we'll go through a little bit of the introductions, a little bit about the lab. Now, we're not looking to like step 1 through step 200 of the manual one by one, right? We want to show you guys some extra stuff, dive into stuff a little bit deeper and give you a good background. So would encourage you over the course of the week to maybe go to the regular hands-on lab section and take the full lab to step through it. But we're going into certain parts of it to give you parts that we think are important and maybe things that aren't covered in the actual instruction set, get a little deeper dive. So today we've got Thomas Kraus from New York. We have Jose Manzancay from Madrid, myself from Minneapolis, Bob, and then Peter Kieran is our captain that owns a bunch of labs. So we're going to be doing the presenting today, and we built this hands-on lab. Little background on vPods. For those of you who might remember vCloud Director, like we build all this stuff on the back end in vCloud Director, and then it gets outsourced to other clouds, including running on-prem at VMware and public cloud. This is a fairly big lab. So we've got over 1.4 terabytes of storage, so each one of your instances is 1.4 terabytes of storage, 380 gigs of RAM, over 120 vCPUs. So we got this times 40 or 50 just here. So they have a lot of instances running in all kinds of clouds, and I'd encourage you to go look at some of the stuff at the hands-on operations center later. We're using the vSphere networking or based configuration here. So we're using NSX ALB instead of the full NSX stack. We'll talk about that a little bit. And this is just don't want to spend too much time on this because we got a lot of content, but basically we've got a layer 1 and layer 2. So layer 1 are kind of VMs that are running on the underlying infrastructure, and then the layer 2 is some of the nested stuff. So you won't see all of this stuff in your lab, but we've got ESXi hosts, it's all nested, so we've got VMs that are being our ESXi hosts and all of our other pieces, and then we've laid down the Kubernetes and Tanzu solution on top of that. So you guys are probably familiar, but vSphere with Tanzu is specifically built into vCenter. So it's got the Kubernetes grid service, Tanzu Kubernetes grid service. There's also additional services like the network service that provides IPAM to the Tanzu nodes and the worker nodes, as well as the load balancing service that comes with either NSX or Avi. We've got a registry service, we've got storage services that provide persistent storage for containers, so that's all built into the product, and that just sits on top of your existing infrastructure. In addition, we do have support for GPUs built into Tanzu, so if you're doing AI or ML workloads, we can actually provision Kubernetes clusters that are using the physical GPUs in your ESX servers as part of a Kubernetes cluster or a virtual machine, and you can use MIG or time slicing so you can carve those GPUs up and provide basically AI and ML capabilities to your virtual machines or your Kubernetes clusters on-prem. So today, like I said, we're not going to cover every single bit of the lab, but we're going to focus on Supervisor cluster, which is kind of the brains of the operation when we get this stood up, a little bit about the infrastructure that sits behind it. And then we're going to talk a little bit about authenticating into the Kubernetes once it's been deployed, use of context, and then we're going to go through actually deploying some applications on Kubernetes. So you're kind of going to get a little bit of the first part, which is a little bit more infrastructure and vSphere administrator type focused. Then you'll get a little taste of the developer side of the house, and some of it kind of mixes in between. So we hope to give you a good kind of a good background on all the different pieces. And I think if you look at the way the modules are laid out in the manual, we're really going to focus mainly on Module 3 and Module 4. So Module 1 has a bunch of iSIMs, so click-through simulators that show how to actually install and enable WCP, as well as how to install and configure NSX Advanced Load Balancer, formerly known as Avi. So that's a good one to take at some other point. It's a lot of clicking through, but it gives you a good idea of what it's like. And then Module 2 talks a little bit about some of the new stuff that happened in vSphere 8 and vSphere 8 Update 1. There were some new things released. And then Module 3 is where we're really dealing with the supervisor and the vSphere namespaces. Module 4 is working with apps, so we're going to focus most of our time on that. Module 5, there's a little bit of information on the AI ML stuff, so you can take a look at that as well once you get out of this session. So, last slide before we move on into the lab is talking about what are we really looking at here. So you guys are all super familiar with the standard vCenter, vSphere configuration, right? You've got hosts, you've got a vCenter, you've got data stores, you've got port groups, and you're deploying VMs for your end users and customers and developer teams. And then on the other side of the house, now we've got Kubernetes, right? And Kubernetes almost has a similar structure. There's control plane nodes up here that aren't really like a vCenter, but a little bit like a vCenter, and then you've got your worker nodes down here, which are a little bit more like where the actual workload runs. And then you've got persistent storage that's provided by the CSI, which is a plugin that knows how to talk to a bunch of different back-end storages. And then you've got a network service that knows how to talk to different network stacks, right? And that all together provides the infrastructure to deploy pods. And pods are the smallest executable thing that Kubernetes can handle. So you can think of a pod as a container, although a pod can have more than one container in it. But a pod is like a container running on Kubernetes. And so instead of running VMs, you're running pods. Well, with Tanzu, what we've done is we've kind of mixed those two together, right? So we start with your existing infrastructure and your data stores and your networks, and we lay down this supervisor cluster, which is a set of 3 VMs that runs the control plane for the rest of the Kubernetes that we deploy on top of vSphere. So it's kind of like the vCenter for our Kubernetes, right? And then on top of that, we leverage the existing data stores and networks, and we can now deploy right alongside your virtual machines. We can deploy TKG clusters, which are Kubernetes workload clusters. They're still virtual machines, but they're all set up and configured to run Kubernetes, and this is where your applications are going to run at the end of the day. So what we're really doing is kind of stitching together your existing vCenter and SDDC along with Kubernetes, bringing those together inside of vSphere, and again, they can coexist with normal VMs and Tanzu clusters. And so we're going to go through kind of how that all works. All right, so I'm going to switch over to the lab now. And that's about as big as I can make it, so little navigation stuff. Again, if you haven't extended, go ahead and please do that. The manual's here. You can press the little button to collapse it or bring it back out. There's a table of contents that shows up here that allows you to kind of do some faster navigation through different sections. So like I said, we're mainly going to start down here in like the module 3 sections and supervisor cluster and things like that, and then we'll go down to module 4 when Thomas takes over. So first of all, what I want you guys to do is just go ahead and launch your Firefox, and that should open up to vCenter automatically for you. You should be able to hit the login key. If the login key is grayed out, just refresh the browser and it'll go blue so you can log in. Should have the username and password saved. If not, it's administrator at vSphere local and VMware 1 bang. Very secret password held. And so what we'll see is we'll just start with our normal vCenter, and you notice we've got 4 clusters down the side. So what I want to start with is kind of the prerequisites for installing Tanzu, right? So as I mentioned, we're using the VDS-backed install, so we're using AVI or NSX Advanced Load Balancer instead of the full NSX stack. And so what we've got here, let's move this over a little bit, is we've got some port groups, just standard VDS-backed port groups, right? These are VLAN-backed VDS port groups. And I've got 3 here of interest to us. I've got a management port group, a data port group, and a workload port group. So these are, again, just normal VLAN networks. And so those are what we're going to leverage when we stand up this solution. You can actually start with as few as 2 of these. You can combine data and workload together if you want, but we're going with the full 3 here. So that's from the networking side. Then the next piece we take a look at is we've got storage, and so each one of our clusters has their own data store. In this case, we're just using local data stores because of the limitations of the hands-on lab, but if these were regular clusters, these would be shared data stores. And each cluster has its own shared data store, so we're not sharing one data store among all of our clusters because we're going to be doing what's called a zone install. So we just got our data stores, and then if we go back and look here, we just have clusters. So we've got regular 3 clusters. In our case, again, we've got single node clusters just to capacity restraints. And so the clusters need to have HA and DRS enabled to be able to install Tanzu on it. You need to have shared storage amongst the cluster itself, and you need to have those networking groups created. And that's kind of your prerequisites before you start installing this. So when you enable workload management, it's actually done up through this menu. There's a workload management option here. And if you click on that, that'll bring up information about workload management, so you can follow along on your stuff. We have a couple different tabs up here. We'll talk about namespaces, but the first thing we're looking at is the supervisors. And so as I mentioned, the supervisor is it's a specialized Kubernetes cluster that gets stood up that manages the rest of the Kubernetes in this environment. And you have a couple different options when you turn on or enable WCP. If you haven't done it and you don't have a license, there'll be a free 60-day trial here, so when you go to this screen, it'll be able to click on Get Started, you'll fill out a couple pieces of information, and it'll enable a 60-day trial. And then what you're going to do is you're going to create a supervisor. So in your case, you wouldn't have any supervisors, so there'd be like a Getting Started button. And this is all shown in that click-through in Module 1 if you want to look at it later. But what you can do is, the workflow to go through this is pretty much a wizard-based workflow. So the first thing you do is you would click on, create a new supervisor. When you click Get Started, you're going to end up here, and it's going to give you a warning that, hey, I don't see NSX in this environment, so I want to use VDS back networking. So it gives you kind of a choice here. If you had a fully prepped NSX environment, you would have that option as well, because we can use either for the network stack. We're not going to talk real deeply about why you might choose one or not here. Thomas and I actually have a breakout session that map B2355 that's tomorrow. If you really want to dig into architecture, there's probably some seats left that you could grab that. But in this case, we're doing the vSphere distributed switch or networking. So that's been selected, and then you'd hit next, and what it's going to do is walk you through kind of a wizard that goes through what IP ranges I want to use, what port routes am I going to use, what storage I'm going to use. And again, this is all covered in Module 1 in the ISIM for installing, so we're not going to do it here because we don't have the resources to install a new one. The one thing I do want to point out here, and we'll talk about this in a few minutes, is when you go to supervisor location, you're going to notice that there's two options here. There's a zone-based install, which is what we did for our lab, which means we actually take 3 clusters and we create them as zones in vCenter, and then when we deploy Tanzu, it basically distributes all the nodes and all the objects across all 3 clusters. So if you have your clusters racked up in a way that you want to get maximum availability, you can use the zone-based. You can also do the cluster deployment, which is a per cluster install, which means I've got a vSphere cluster, I'm going to enable Tanzu on one vSphere cluster, and now I've got a supervisor for that vSphere cluster. And then if I need more capacity, I could add ESXi nodes to that cluster, or I could just enable Tanzu on another vSphere cluster, right? So you can just kind of add. So you have a choice of doing a zoned or just a single cluster deployment out of the gate. We did zoned here because that was new in vSphere 8, so we wanted to show that off. But again, there's reasons why you may do either or. And then what would happen is you would see any clusters that met the criteria down in this table. Now we only have all of our clusters are already used, so we are not seeing any. But if you don't see a cluster there, you would see it under incompatible and it would tell you what it's missing. I don't have DRS, I don't have HA, I don't have my storage set up right, something like that. So it gives you an idea. And then once you would click on that, it would step you through the rest of the wizards to get it installed. And so once you have this stood up, you can get this up and running in just a couple hours on your existing infrastructure. Really, most of the time is kind of windshield time just watching stuff provision. Once that supervisor cluster is stood up, I'm just going to cancel my setup here. You'll see it listed here, and it gives some information about whether it's healthy or not in running state. It gives you the IP address, which is the highly available VIP provided by Avi for the Kubernetes API and things like that. And we'll learn about that more a little bit later. But if you look at the kind of information it's actually asking for during the install, I can actually click on this cluster and look at some of the configuration items. And one of them is like the networking, right? So first of all, it's going to ask you about the management network. So this is a management interface that these supervisor cluster nodes are. This is how this guy talks up to vCenter. So all the information between the WCP service running on the cluster and vCenter happens on that particular configuration. And so you give it an IP address, a starting IP address, and it's going to use that plus the next 4 in that range. And that gets used for the supervisor control plane nodes and an HA VIP for those nodes, and then a failover or an extra address for when we do upgrades. We do rolling upgrades, so we'd slam a new node in, use that last IP, upgrade it, take one of the old nodes out and just roll through the cluster. So it's 5 IPs that get used there. And then basically, subnet mask, gateway, DNS, that kind of stuff. So what this interface does, and we'll look at this when we look at the supervisor nodes, this is responsible for talking up to vCenter and the WCP service that runs on vCenter. The next network we would have is going to be the load balancer network. So in this case, we're using, again, NSX Advanced Load Balancer. And so what that does is we connect this to the NSX Advanced Load Balancer controller. so that it can exchange information. And then we give it a password and some certificate information. And then Avi is already, or NSX-ALB Avi has already been configured with a pool of addresses on that data network we looked at, that VDS data network. And it uses that to hand over load balanced IPs. And so when Thomas gets to the part where he's installing an application, he'll talk about this application's getting a VIP or an IP from Avi. That's coming from this interaction and this network pool that we've given Avi to say, hey, when I install something on Kubernetes that needs a load balancer, I'm going to just automatically issue an IP out of this pool that you've already given me. So you get the cloud-like experience of basically load balancer as a service. It's just there. You don't have to put tickets out to the network team to get a load balance VIP for this app figured out. All this stuff just happens automatically. So that's what happens with this part of the configuration. And then finally, there's the workload network. And again, this is another one of the VDS networks. So you see here, we've configured the VDS workload network. We've given it a starting IP address and a pool. So again, as I create workload clusters, those TKG workload clusters that are running Kubernetes where your apps are actually running, we're automatically going to just service all the IPs out of this. And you can have more than one of these. So when you create namespaces, you can choose which one of these networks it gets assigned to it. So you can have some that are running secure apps that's maybe on a VLAN that goes through additional PCI compliance or different firewalls. So there's a lot of control that you have over the infrastructure as to what happens. And so as the vSphere admin side of the house, they're going to be, you or they're going to be responsible for basically doing this initial setup to get us to the point where we have the supervisor cluster up and running. All right, so I'm just going to pause real quick. Everybody accessing, everybody follow along, everything good? Okay. So one of the other things that happens when we go through this installation wizard is we also configure a content library automatically. And since we're in Hands-On Lab, we're using an offline content library, because you can do this air-gapped. You can pull down the images and put them in a non-subscribed content library. The product automatically will create a subscribed content library to our CDN, and that's where it actually pulls down all of the OVAs for the TKG workload clusters. So when you actually create a workload cluster, which Thomas will talk about in Module 4, we're actually going to deploy those VMs from an image that's already in the content library that has all of our bits installed on it. It's got all the pieces required to do Kubernetes, and as we issue new versions of Kubernetes, they'll just automatically show up if you're using this content library. So you might have 20 or 30 images in here. It's configured to not pull them down all at once. It just pulls down the metadata. So you're not going to fill up your storage with a bunch of things you may never use, but they'll be there if you need them. And when we go through Module 4 on how to create a cluster, you'll see how these get leveraged. So this happens to be a 124 Kubernetes based on Photon. We also ship images with Ubuntu OS, so you can use either of those. And we'll have many different versions of Kubernetes that are out here to be used. So that also happens during install. So now we've got everything installed. If you want to go to your inventory view, we'll kind of expand these clusters out a little bit. So, as I mentioned, we did a 3-zone install. So you see I've got these 3 clusters, Comp 1, Comp 2, and Comp 3. What I've actually done is in vCenter, before we installed this, we created zones where we basically create the 3 zones and we add a cluster to the zone. So that's how we kind of get our zone-based deployment. And then before we install it, we also create a storage policy. And you can do storage policies a lot of different ways. You can use them by basically tag-based storage policies or zonal-based storage policies. So for ours, we did Tanzu, one called Tanzu, and we created it in a zonal range. So that means that each of those clusters has their own shared data store in the cluster, but it's not shared across all 3 clusters because that really breaks the premise of an availability zone. You want everything in each zone to be dedicated to itself. So basically after we did this, when we installed it through the wizard, we chose the zone-based deployment instead of the single cluster. And what happened is, the first thing that happens is you get this namespace object that looks suspiciously like a resource pool that gets created on each of these clusters. And then those supervisor VMs I talked about, there's 3 of them, so since I got 3 zones, I'm going to get 1 supervisor cluster per each zone. So even though these are 3 separate clusters, we're basically distributing that automatically through that cluster. If this was a single cluster, we would distribute it between the hosts in the cluster using compute rules so they don't live on the same host if possible. But in a zonal one, what happens is we're actually going to take these guys and put one on each of the 3 clusters in the 3 zones. So that's the first part. And the supervisor cluster, like I mentioned, is kind of the brains of the operation. So if we look at one of these virtual machines, if I can get this slid over, maybe, maybe not. Yeah, there we go. One of the things you're going to notice is we've got multiple networks on these, and this talks about it in the lab on page 43, or actually I think it's like 32, 33, 34, something like that in the manual. Let's just see here. Supervisor cluster. So yeah, if we go to page, I think it's like 42. Yeah, so we're kind of talking about that right here and how these are distributed between each of the clusters and the namespace objects, and then the supervisor cluster underneath it, and the vSphere zones we looked at. When we look at these supervisor clusters, they all have 2 NICs on them. And so they're going to get 2 different IPs as part of this. The first IP is going to come from our management network. So this is that one, that management port group that talks up to vCenter, and this is where all the vCenter to supervisor cluster traffic goes. There's a second NIC that gets assigned here that is on that workload network, and that's how it talks down to all the workload clusters that it creates and manages. So the supervisor cluster's job is to create and update the lifecycle management of all your Kubernetes clusters. So we're using a technology called Cluster API, and Cluster API uses Kubernetes to deploy Kubernetes. So it's kind of the whole Kubernetes supervisor cluster is a little bit like your vCenter. It manages the lifecycle of all the Kubernetes clusters that are underneath it. And we'll look at a few of the things that are on this one. But because of that, and because of the initial configuration with NSX, because the NSX overlays aren't routed outside of NSX, it's got 2 NICs so that it can talk down to isolated networks and up to vCenter. They kept the model when we're using VDS network, so it still has 2 NICs. It's just now that this network isn't an overlay network. It's just another port group on a different port group. It's another network. And so it's not isolated, but it still keeps that model so it's consistent between the 2 stacks. So you'll see that one has, a lot of them have 2 NICs, and if you scroll through the 3 of them, you're going to have one that actually has a total of 5 addresses instead of 4. And so the one that's got 5 addresses, you'll see it's got an extra address on that management network, and that indicates the etcd leader. So Kubernetes uses a database called etcd. It's a key value database that basically tracks all of the objects that Kubernetes knows about. And so we create a highly available VIP on the node that is the etcd master, because it uses a master election process. And so vCenter will always be talking to that highly available IP. So if one of the nodes crashes for some reason, that highly available IP gets picked up by another node, and so vCenter always has a predictable place to talk to the supervisor cluster. That also comes into play when we do things like upgrades, where we're spinning up a new node, and eventually that leader is going to end up somewhere else on one of the upgraded nodes. So that's the mechanism there, and that's why you'll see on these, sometimes one of them or every time one will have one more IP than the other 2. So that's basically the supervisor VMs, and we're going to look at what's on those in a second. The other thing I wanted to call out is we're going to create a vSphere namespace in a second. So one of the other things you'll see on each one of these clusters is this ecom stage 1 namespace. So those of you that are familiar with Kubernetes know that namespaces are really a way to like segment apps or create RBAC boundaries or things like that on a Kubernetes cluster. And when Kubernetes first kind of came around, you'd create these huge Kubernetes clusters, and you'd use namespaces to segment out teams and apps and things like that so they could only see their stuff. Well, what we've done in Tanzu is we've taken that concept and really built it into an RBAC and a resource boundary for the vSphere administrators to control what happens underneath it, because under these namespaces is where the actual Kubernetes workload clusters live. And so we're going to look at this in the next module. But like this is a cluster called TKG Cluster 1, and there's the 2 VMs that are on this particular vSphere cluster. And if we look at one of the other vSphere clusters, we'll see 2 more nodes for this cluster, because again, we're using them as availability zones, so we're just like the cloud, we're striping or distributing those nodes across all 3 of the clusters. So hierarchically, this cluster lives in a vSphere namespace. It doesn't really live in a vSphere namespace, right? This is a Kubernetes management thing. So Kubernetes is tracking all the objects in Kubernetes that are related to this particular cluster via this namespace in its etcd database. But at the end of the day, these are VMs running on your ESXi hosts, okay? They're not some super specific special type thing. They're a VM running Kubernetes, running on your node. But the management layer above it, this vSphere namespace, allows you to do all kinds of things around setting up who can see it, how much resources they can use, what data stores I'm going to use, all of those types of things, right? So it's an administrative boundary. Usually you would set those up between different lines of businesses or maybe different applications or test dev environments or anything like that. So they're really used for that. So because we started a little bit late, I'm going to just jump into the last part of my module, which would be go through and actually create one of these vSphere namespaces so that you guys can see what's all kind of part of that. And if you go in your manual, it's going to be on page, let's see here, it'll be on page 56, I believe, is where we cover that. So we're going to create, that's where you start talking about namespaces, and then on 56 right here, we're going to talk about creating a new vSphere namespace. So if you guys just go up into your pull-down menu, your stack menu, go to workload management, you'll see one of the tabs across the top up here is namespaces. And so we've already got our supervisor stood up, so we have the capability now to build namespaces on the cluster that the supervisor is enabled on. So if you go to namespaces, you can go and click new namespace. First thing you do is you pick which supervisor cluster we're talking about. So you'll notice here, we only see one supervisor, even though there's 3 clusters underneath it. It's a single supervisor for those 3. If you had multiple clusters enabled with their own supervisor, you may see a list of numerous supervisors here. You can have up to 50 Tanzu enabled clusters in a vCenter. So you could enable up to 50 clusters with Tanzu if you want to. So we pick which supervisor we're interested in, and then we give it a name for the namespace. And it says a DNS compliant name. All that means is lowercase, only hyphens and underscores, letters and numbers. No capitals, no weird characters or anything like that. So in the lab manual, I think it has this great one called infratools.prod. The name really isn't that important. We're not going to be leveraging it after. So I'll type that in, and we'll go ahead and hit next. You notice I mentioned that you could have multiple workload networks, and we had only configured the VDS workload one. So this is your first administrative boundary. You can stitch or connect a specific workload network where the Tanzu nodes are going to be deployed, the Kubernetes nodes are going to be deployed to a namespace. So again, if this is a PCI namespace where you've got stuff, or maybe there's a sensitive database that you only could connect to from certain port groups in your vCenter, you would be able to select that port group here as what choice you wanted to make it had you added it to the options when we installed. You can always go back and add them later. So then when I create the clusters, it's going to be created on, they'll be attached to that network. So it gives you a little tip and says, okay, now you probably want to go through and do some stuff like adding storage and doing a few other things. We'll dismiss that, and we'll go through and add permissions. So as I mentioned, a vSphere namespace is really about RBAC and resource boundary. So the first thing we get to do is decide who can see this, and this will come into play when Thomas gets into logging into the, through the command line to the Kubernetes supervisor cluster and the namespaces. But any identity source that we have available to us as part of SSO and vCenter can be leveraged here. Now I don't have AD tied in, but if you got AD or some sort of federated identity, you can pick users and groups from that identity source, and it actually sets the permissions up. The supervisor cluster along with vCenter handle all the authentication into Kubernetes. So you don't have to deploy anything separate. Now you do have the ability to use like a third-party provider called Pinniped on the workload clusters if you want to do something different, but you start with whatever you have tied into your SSO. So if you got AD here, so I'm just using our vSphere.local, and I'll just grab a user here. I'll grab my administrator. Well, I didn't really type very well there. So I can pick that, and then I would be able to select roles. And so there's 3 different roles at the namespace layer. There's a view role, which means if I'm a developer, I can see all the clusters that are underneath this namespace and I can use them for my apps, but I can't create any new clusters. Because one of the things that Cluster API in Tanzu allows is self-service Kubernetes. So once the administrators have stood up the supervisor cluster, You can allow your development teams or your SRE teams to deploy their own clusters, and Thomas is going to talk about that. It's very simple with a simple Kubernetes manifest. Since we're using Kubernetes to deploy Kubernetes, kubectl apply -f with the file name, the whole cluster gets stood up in a matter of minutes and you have a fully functional Kubernetes cluster ready for the dev teams. So you can choose if you want to do that, you want to lose certain teams to do that, or you want the developers to do it in their own like sandbox. You have all those roles. So the first place you make that decision is right here. And so if you're an owner or an edit, right, you can create vSphere or Tanzu Kubernetes Grid clusters in this namespace. So in this infra tools namespace, I would be able to create a cluster if I have one of those rights. If I'm view, I'm able to view and use them, but I can't create them, okay? So that's kind of the first thing. So we'll just set that and hit okay. The next choice is which storage do I have access to. So you remember I said we created a storage policy. You can have multiple storage policies created. We only have one created. So what this is used for, this initial storage policy, is going to be where, when I create a Tanzu Kubernetes Grid node, my disk lives for those VMs. It also gets used for persistent storage for containers. So if my developers deploy an application that actually has a persistent volume connected to it, then they'll use that to do that. Store there, and you can add more than one of those. And then quickly, you can set limits. So as you get experience with the size of your clusters, you can actually sit there and decide, okay, I only want this team to be able to consume this much storage, this much CPU, and this much memory. And so you can set those, so even if you're giving self-service to create clusters on this, you have some control about how much of your capacity they consume. So they can't just create the largest ones. Another thing you can do to control that usage is we have these VM classes. So these are a bunch of pre-configured t-shirt sizes of VM sizes that we have out of the box. And by default, we don't allow any of them on the namespace. You, as an administrator, get to choose what size VMs do I want my people to deploy. So you can check which ones of these you want to allow based on CPU and memory in this particular namespace. So if you guys have a corporate standard, you can pick it and define it here. You can also manage VM classes and make your own custom VM class. So you can go ahead and set your own. If you have a corporate standard that you want for Kubernetes, you're able to set it there. And I mentioned the stuff with AI and ML. If you have GPUs and you followed the process, you would be able to pass through part of a GPU, either time slicing or MIG, into these VM classes as well. So you have a lot of ability to customize these. One of the things to pay attention to is CPU reservation and memory reservation. So you can set those custom, and when we looked at these classes, you'll notice that there's some that are called best effort, and some that are called guaranteed that we make out of the box. The best effort ones have no reservations whatsoever, so you can oversubscribe. Those would be great for like dev sandboxes and labs. The guaranteed have reservations for 100% memory and CPU, but you can make your own that maybe only does 50-50 or something. These are what you'd probably want to use for like clusters running production workloads. But again, you have all the flexibility to set this on the namespace when you're going through and setting this stuff up. So it's one of the choices that you get to make. Just know that you have to at least set one, or nobody's going to be able to deploy anything in here, right? It's because we don't pre-select any. And then finally, we have some things with different content libraries. So if you had certain content libraries, or you were going to use the VM service to deploy a VM, which Thomas will go through, you'd be able to set up the content libraries for those as well, and he'll talk about that coming up. Okay, so because we started a little bit late, I'm going to cut it right there and get Thomas up here. While we're swapping, anybody have any quick questions on the part that we just kind of talked about? Makes sense conceptually at some level? All right, well thank you very much, and here's Thomas.
Can you guys hear me? Awesome. So this is going to be a module about Tanzu Kubernetes clusters. We're going to go into what a TKG cluster is, deploy a simple stateless application on top of the cluster, and then we have a module where we're going to go in a more complex multi-tier application called Spring Pet Clinic. And I'll show you how we deploy that in a way that makes a lot of sense for a DevOps team. So when we get to that, I'll cover that in a little bit of detail. I'm going to be sitting down because I'm going to be doing a lot of typing. We're going to be in the terminal a lot. So pardon it's going to be kind of a light terminal. So like Echo, LS, grep, kubectl. It's not going to be terrible, but try follow along. I'll do some extra stuff to show you what's going on behind the scenes. And if you have any questions, just raise your hand and one of the proctors will come by and help you out. So let's get set up here. All right, so before we get to the terminal, let's go ahead and take a look at a namespace. Bob created a namespace. He showed you what's going on. I'm going to show you the namespace that's already been created, and we'll see what's in there and how it relates back to the Tanzu Kubernetes cluster that we're going to create in a minute. Or that's already been created, I'm sorry. So if we go into this ecom01 namespace and I click Manage Namespaces, we already have some permissions that have been set up. We have some PVCs and a storage policy. So part of this declarative cluster API apparatus is that this storage policy is going to be exposed as a storage class inside the Tanzu Kubernetes clusters we deploy. So we'll look at that manifest and see where all these objects map together. And if we go down a little bit, we can see our, we can see the virtual machine service running, and we can see the VM classes which have been associated with this namespace. So these are like my t-shirt sizes, Bob said. So inside that manifest will be a reference to one of these t-shirt sizes that we're going to deploy. So if you guys could fire up your terminal, PuTTY, and then on the bottom you're going to see a Linux 01 corp vmbeans.com session. Open that up. So let's take a, first thing we're going to do is log into the supervisor control plane namespace. So a vSphere administrator is going to create that vSphere namespace. He's going to provision a cluster, and then he's going to give a DevOps guy or a developer access to that cluster. So right now, we're kind of a DevOps guy. We're going to go inside that namespace. We're going to see the cluster that's already been provisioned to save time. Normally, we would be the one that's provisioning that Kubernetes cluster inside that vSphere namespace. And you're going to see me go back and forth between vSphere namespaces and Kubernetes namespaces. I apologize, it's a little confusing, but I'll try and delineate when I'm talking about a vSphere namespace that we're seeing in the vSphere client and a traditional Kubernetes namespace. Okay, I'm going to create a quick alias because I hate typing. So now as our DevOps guy, we've logged into the supervisor cluster. We have access to some Kubernetes context, and a context is a reference to a Kubernetes namespace, or in this case, a vSphere namespace, or other Kubernetes clusters that I can get access to. So right now, our active context is set to the previously deployed TKG cluster 01. So I'm going to show you guys what this looks like when we go in and look at the objects inside Kubernetes. So this is what a reference to a YAML manifest for a Tanzu Kubernetes cluster looks like. We're using cluster API, so the object type or the kind is a cluster, and then we decorate that cluster with our specific technology using classes. So the cluster class is Tanzu Kubernetes cluster. You can see it under topology class. The Kubernetes object type is a cluster object, a native upstream cluster API cluster object. And then we see references here. We have a name object like most Kubernetes objects. We have the namespace it's being deployed to. That's our vSphere namespace. We have the machine deployments. We're using a zone-based deployment. So we're going to span those Kubernetes worker nodes, 3 of them, across the different vSphere zones and vSphere clusters for high availability. And when we build deployments on top of this Kubernetes cluster, those deployments will automatically span across those vSphere clusters for resiliency. So we have a class, Tanzu Kubernetes cluster. We have a version here, v1.24.9. That's the Kubernetes version. That's called a TKR. We'll see how we found that version that was available to us in this vSphere namespace and how we filled that in this manifest. We have our t-shirt size here under variables and VM class. It's called best effort extra small. So that's going to be the size of our worker nodes, and that's going to be the size of our actual control plane nodes for this Kubernetes cluster. And then we have storage classes, and these storage classes are a one-to-one mapping back to a storage-based policy inside vSphere. So we took a collection of data stores, we built a storage policy, we tagged it, and now we refer to that in our Kubernetes YAML manifest for this cluster, and those storage classes are going to be created based on the data stores in that storage policy inside vSphere. Okay, so the cluster's been provisioned. Let's just take a quick look at some other stuff. So if we get storage classes in the Kubernetes CLI, we can see we've got Tanzu default-SC. There's a storage policy inside vSphere called Tanzu default-SC with a group of data stores in it. That's now available to automatically and dynamically create persistent volumes for clients inside this Kubernetes cluster. And they'll get striped across those data stores. And we can provision one or more storage classes to a Kubernetes cluster and have them available. We can have a default storage class so that you don't have to specify the storage class when you create your PVC. And then we'll look at some other things. So let's look at virtual machine classes. I spelled it wrong. I can't see. Let's do TKRs. Okay, CTX. Okay, I'm in the wrong context. So I'm focused on a Kubernetes cluster. I want to be focused on the vSphere namespace. So those objects, like a virtual machine class, a TKR, they don't exist inside my Kubernetes cluster, TKG cluster 01. They're only in that vSphere namespace. Those are CRDs that we've added to the Supervisor cluster to be able to manage objects in these underlying clusters. So I'm going to go back to my context for the vSphere namespace, ecom 01, stage. And we can see our running cluster, TKG-cluster 01, that's our running upstream Kubernetes, Tanzu Kubernetes grid cluster. We can see the storage classes again that are available in that cluster. And then we see those t-shirt sizes, so anything I build in this vSphere namespace can be one of these 3 t-shirt sizes, and those are managed through the vSphere CLI. I can add and remove t-shirt sizes. So if I'm building a standalone VM, which we'll do in the Pet Clinic app, or I'm building a Tanzu Kubernetes cluster, I need to be able to control the size of those clusters and how big those nodes are, and that's how we do it with these sizes. So these would get mapped into that YAML file. We would do a kubectl apply of this Tanzu Kubernetes grid manifest, and we've already done that for you, and that's what you see running. That's what you see running here in the vSphere client. So that cluster maps directly to this guy. And again, we striped it, 3 control plane nodes, 3 worker nodes, 1 control plane and 1 worker node in each zone, striped across the 3 availability zones. So they have their own unique storage, their own unique vSphere cluster. So we'll deploy a simple application. Actually, let me just pause there for a second. I'm going a little bit off script. Any questions on where we're at? Is everybody kind of caught up and aware of what this is? So the next step is we're going to deploy a stateless app, just a simple Nginx application, but this is going to show you what a Tanzu Kubernetes cluster is. Because of the way we configured Tanzu, every time you build a Tanzu Kubernetes cluster, you get the persistent volume support and the load balancer or possibly ingress support automatically configured in the cluster for you. So if we change directory to labs/nginx, I believe it is, and do an ls, You see this Nginx deployment and an associated Kubernetes load balancer. Let me change that to less so we can take a look at that. So the first thing we have here is a service, Nginx. The selector is looking for a key value pair of app:/Nginx. And then we have a deployment with 3 replicas of our Nginx pod. So let's just make sure you're in the right context. So we're not. We're going to switch back to the Kubernetes cluster. We're not going to deploy this inside a vSphere namespace. We're going to deploy this inside our TKG cluster. So KCTX and then TKG-cluster01. If we look at pods right now in the default namespace, there's nothing. So we'll deploy this manifest. We'll have some pods running on our Tanzu Kubernetes grid cluster. We can see they're running and creating. If you do a kubectl get service, we can see the load balancer, the L4 service that was created from that manifest, which is going to create an Avi virtual service and a virtual IP for our Nginx pods automatically. And it did the IPAM for us, and it assigned an external IP of 192.168.130.15. So just quickly go to that, and then we'll pause and kind of see where everyone's at. So this is the Nginx pod, the load balancer to our 3 Nginx pods. If we take a look at Avi, we now have a virtual service. Right here. So it has our cluster name, the vSphere namespace, and then a dash, and the name of the service that we created. And we can see our the endpoints that sit behind this. We can do health checks on this. So this will keep track of our Kubernetes objects. There's a pod running on the Supervisor cluster. If I scale the Nginx deployment right now and change it to 6 replicas, this is kind of the beauty of Kubernetes. Avi will pick up on that. It'll tell the Avi controller to spin up 3 more backend load balancer pool members, and it'll wire everything up. So why don't we do that? We'll look at the deployment. So this is kind of the beauty of Kubernetes, right? I can just dynamically scale the front end of this application. It's not a multi-tier application, it's just a simple web app, but I can scale this very quickly. And I now have 6 replicas. If I do a Kubernetes endpoints, I now have 6 endpoints sitting behind that represent those pods. Avi updated the backend pool members, and instead of 3 pods behind that load balancer service, I now have 6. So just very simple to use and troubleshoot, and all of those things are done for you. So when you deploy Kubernetes, it's not that difficult, but getting persistent volume support, getting load balancer support for access outside the cluster, that's kind of those last mile things that get a little bit tricky for like production deployments. So I'm going to take a quick pause there. Was everybody caught up to where we're at? Other people having that problem switching context back and forth? Okay. So the command is kubectx. KUBECTX. That's how you switch back and forth. And the Nginx part is kind of like a brief introduction. I'm going to kill that now. We're going to do Spring Pet Clinic, but let's just make sure everyone can switch context back and forth because that's kind of important. So, how many people don't know what a context is in Kubernetes? So, okay, sorry, that's my fault. You guys were in the first session, so A context in the kube control CLI is an association with a cluster and a namespace and your authorization information. So you have a kube config file that's sitting on this lab, which could be referencing multiple clusters, multiple environments, or different namespaces on the same cluster with an auth token to log into them. Using kubectx or the kube control command to change context is going to give you the credentials to get and do things on those various clusters. And when we use the vSphere logging command, it populates our kubectx and our kube config files automatically. So when I logged into the Supervisor cluster, it returned me a token and updated my kube config file for everything that my user account had access to in our environment. So that's the Supervisor cluster, that's the vSphere namespace ecom01-stage, and that's the cluster tkg-cluster01, as well as the new vSphere namespace that Bob created called infratool-prod. So is everyone able to kubectx to the TKG cluster? TKG cluster 01? Anybody not on the context for the TKG cluster 01? We'll just get you guys on that context and we'll deploy the Spring Pet Clinic app. Nginx was just kind of like a trial run, so. Sorry about that. I'll also get to the main section where what we're covering. So right now we're on page 95 of the manual, if you want to follow along on the manual. So Spring Pet Clinic is a Spring-based application. It's multi-tier microservices based. And originally it calls for a MySQL database, or you could store it in an in-memory database. It's very flexible, the architecture. The reference architecture calls for the database to be stored on your Kubernetes cluster. But that can be a management model that some people aren't familiar with. So what we're going to showcase here is putting the Kubernetes objects for the front end and the middle end of the application on your TKG cluster, but keeping the database as a virtual machine, but it's also managed by Kubernetes. We have a VM operator service or a VM service, which you're going to watch me deploy this YAML, and that YAML is going to actually deploy a back-end virtual machine and bootstrap MySQL on the virtual machine, but we've done it all from Kubernetes using Tanzu. So think about a multi-tier application where you don't necessarily want all the pieces to sit inside Kubernetes. Maybe you just want the load balancing tier and the middleware tier to be on Kubernetes, and you have a physical database or a mainframe or something else you have to access. You can describe all that in a GitOps fashion, put it in source control, submit it to Tanzu, and the pieces will get deployed. Some Kubernetes pieces, some traditional virtual machine pieces. So if we go into the labs pet clinic folder, so you guys are in a home/HOL user. If you switch into labs/pet clinic, we'll look at what that consists of. So if we look in this MySQL directory, if I could type, I have two files. One's a Cloud Init file. Cloud Init is a configuration to bootstrap this VM. It's an open source project that's used to configure virtual machines on first boot. And then I have the description of our virtual machine. So if I look at that description, so we're going to look at that, the MySQL-VM-SVC-VM-VDS. And the kind is a virtual machine object. We can look at the selectors for the object, the namespace it's going in, the image name. This image is not a Kubernetes or a Docker image. It's a virtual machine OVA image, and it's stored in the content library. That's where we're going to pull this from. We have a network type, and we have some readiness probes, as well as a config map. So this is like a modern application. We're storing config data somewhere else, secrets data somewhere else. We're not embedding everything in the application. And then I have a service to expose the MySQL port for this MySQL instance outside to my front-end Kubernetes pods. So if I want to scale the MySQL instances or cluster individually, I can do that. There's a load balancer sitting in front of them which will update. And one of the nice things about Kubernetes is if I do a Kubernetes explain, like I said, a virtual machine object is a custom resource that we created and we support. Kubernetes allows you to extend the API. So if we explain what a VM is, I'm on the wrong cluster, so I'm still on TKG cluster 01. We're going to switch back to the ecom namespace. Ecom dash. So we can query the Kubernetes API and look at this custom resource definition and say, tell me what it is. What is a virtual machine object according to this Kubernetes cluster, or this Kubernetes namespace? And we can see it has a kind, a metadata, a spec field, and I could drill into each one of these and see what the required parameters are, and almost use it to build my manifest for me to deploy a virtual machine on top of Kubernetes. So let's go ahead and apply the virtual machine object to the vSphere namespace and get our virtual machine up and running with CentOS and MySQL. So that's the command. We're going to apply the MySQL. We're going to apply the MySQL-VM service-VM-BDS YAML inside the MySQL VM service folder, which is in the Pet Clinic folder. So we created a virtual machine object. We created a config map to store the configuration for our virtual machine, and we created a virtual machine service to expose the MySQL port. Those three objects were in the same YAML that we just applied. If we go into Avi, we can see that we've started to provision a MySQL VM service automatically based on that YAML manifest. The pool is down, right? Because the virtual machine is still coming online. If we go into vCenter, we should see an OVA deploy. If you're unable to deploy that virtual machine, just raise your hand and somebody will come by and help you. So we're in the ecom 01-stage context, and we're applying the manifest that you saw up on the screen. And if we come into vSphere, and this is hard to work with. Okay, so our OVA deploy happened already. The machine's been powered on. It's probably coming online. If we go to our ecom 01 stage namespace, in one of those three zones, we should see our CentOS VM. There it is. So inside the namespace, we have ecom 01 stage namespace, vSphere namespace. We already have the TKG-cluster 01 deployed. If I expand this, we'll see 6 virtual machine objects that got deployed when we applied that manifest. It was done for you, we never applied it, but that manifest we looked at, basically under the covers, deploys virtual machine objects. And then we have our standalone MySQL VM that's running MySQL with a service exposed on Avi, And now we're kind of ready to stand up our Kubernetes components, which is the middleware and the front end for the Pet Clinic app. So let me just use the manual a little bit so we can keep you guys up to speed on what we're doing. We have the virtual machine object. We have our service created for the virtual machine object. What we didn't do is look at the virtual machine object. So we can see our MySQL CentOS VM inside the vSphere namespace, and we see the cluster node VMs inside the namespace as well. If I do a get service, I can see a MySQL-VM service inside the vSphere namespace, listening on port 100, IP address .100, and it's listening on SSH and the MySQL port, 3306. So that's how our front-end components that we deploy on our Kubernetes cluster are going to get to the back-end database, create tables, populate the tables, and we'll get our application up and running. So I'm going to go into the Pet Clinic folder, petclinic.k8s. If everybody could just cd into labs/petclinic/petclinic-k8s. And then the other thing we'll have to do is we're going to switch to the Kubernetes cluster. We can't deploy pods and deployments native to Kubernetes to a vSphere namespace. We got to put those in a Kubernetes cluster. If you can, I don't know how much resources we have in these clusters. If you're able to get to the context for the TKG-cluster01 and do a Kubernetes or kubectl delete or a k delete deploy nginx, just to free up some resources. So k delete deploy nginx. I think we should be fine, but just to be safe, let's get rid of the old nginx deployment. So the first thing we're going to do is create a new Kubernetes namespace, not a vSphere namespace. We're inside a Kubernetes upstream cluster. We're going to create a Kubernetes namespace. So we're just going to apply the on-namespace YAML. And we can see we've now got a Spring-PetClinic Kubernetes namespace on our cluster. Everybody good, or anybody need help? Help? Okay, next thing is we're going to deploy the services and components for this front-end application. So with the kube control command, I can just point it to a directory. So I'm going to point it to this services directory, and it'll apply all the manifests in there. And we'll take a look at what those manifests are. But we're going to do a k-apply -f, not -g, sorry. So we got a secret, we got a config map, we got role bindings, we have services for 4 microservice components. So there's a separate service created internal to Kubernetes for each of the components. The database, the customer database, the pet database, the visits database, and the API gateway, which is going to be the front end for our application. So if I do a Kubernetes control get service now, I now have a new service called, no I don't, hold on, sorry. So if I look inside the services in the Spring Pet Clinic namespace we just created, I now have 4 services. One is our front-end service using load balancer type. The other 3 are internal cluster IP services to talk to each other. All right, next step is we've deployed the namespace. We deployed the services for our application inside the namespace. Now we're going to deploy the actual pods and deployments for the components of the application. You saw this. If we look at the endpoints for the services inside the Spring Pet Clinic namespace, we don't have any. We haven't deployed the actual pods which sit behind these services. So let's do that. All right, we're going to apply all the manifests in the deployments directory. So we can see our containers creating, the customer service, vet service, visit service. These have a pre-stage that will actually, in the pod, it's going to actually talk back to MySQL and create the tables on the same database that the application needs, and then populate them with some sample data. So it takes it takes a while, and when that happens, a health check in Kubernetes comes back and says that application or that pod is now healthy. So we're waiting for that to happen. You can see it starts happening now. Visit service is up, vet service is up. Once the customer service comes online, then we should see the API gateway come online, and we'll be able to access the front end of our application. Okay, so now this looks a little bit different now. We have cluster IP services, and we have our API gateway service. We've been assigned a front-end IP. We should be able to get to our application now on that IP address. Avi should have stood up a virtual load balancer or a virtual IP and made the pool members. We only have a single pod in that API gateway service. Yeah, we have a single pod in the API gateway service, but if we go back to Avi, we have our TKG cluster and our service coming online. And we should be able to go to the IP address 192.168.130. Whatever you got assigned. In my case, it's 16, and we should be able to see our application. Now this is just the front end. This is that API gateway. To test the entire application, yeah. So I'm now hitting those backend services and the backend databases in MySQL with those tables that the applications and the pods created for us. Is everybody at that point or no? Yeah, good, no? So we can look at it through the web page. We have some health checks on the app that we can check. And we could also go and look at the objects that were created for us. This is a good test application. There's multiple tiers. They're talking to each other internally, as well as talking to our VM service, exposing MySQL on another Kubernetes service inside the namespace. And then they also have persistent storage, and they're testing all of the different Kubernetes components for us. So let's look at the persistent volumes and PVCs inside that Spring Pet Clinic namespace. So we see we have a PVC for the API gateway. It's been bound. So if we go into vSphere right now and look in our data stores, or we can go into the namespaces. We should see a VMDK associated with this PV that got automatically created for us and is a Kubernetes object pointing back to a VMDK on top of vSphere. So if we go to that ecom 01 stage namespace, we go to manage namespaces, and then we go to storage, we can see our persistent volume claim for that application we just stood up. We can look at the YAML manifest, we can look at performance. So I hope, okay. I'm going to stop here and just maybe ask or answer any questions. I hope this gave some indication of what the capabilities are. I know we bounced around a lot and went a little bit fast. I apologize that. We're going to figure out how to increase the font inside this lab session. Any questions for me or Bob or I? Did everyone understand the value of deploying an application, multi-tier application, and being able to deploy a VM through the Kubernetes API, as well as pods, deployments, services? Was that, okay. All right, cool. So we want to thank you guys for coming at 9 a.m. on the first day of the conference. I think this was the first event, and we're really thankful for you guys being here, and thanks for your patience.